Okay, good. We're into chapter 1 now in your book, and this video is actually going to be a relatively brief one because I'm convinced it's a topic you all know. I just want to quickly run through the basics to make sure we're clear. And we just want to talk about the rectangular coordinate system. Basically, how to graph points in the plane. So, all of you have seen the plane before. Rectangular coordinate system, the XY plane, the Cartesian plane, if you want to be really cool and mathy. But essentially, the horizontal represents X, the vertical represents Y, and then you have points in the plane, and you have these quadrants. There's 4 quadrants right here, as far as numbering them goes. We start in the top right and call that quadrant 1. Then we go in counterclockwise order. Top left is quadrant 2, bottom left is quadrant 3, bottom right is quadrant 4. And you want to have a working knowledge of these so that you just understand, oh, this point is in quadrant 2, that point is in quadrant 4. So, all we really care about for right now is how to plot points. So say I have the point 2, 4. The first component there is my x value. The second component is my y value. On the coordinate plane, the center, which is called the origin, is the point 0, 0. And then essentially, positive is right and up, negative is down and left. So, if I want to find the x value 2, I go over 2. 1, 2. I want to find the y value 4, I go up 4. 1, 2, 3, 4. And then there's my point 2, 4 right there. I'm aware you've probably all done this before, so I don't want to spend a lot of time on it. But if I have the point negative 3, 5, I start at 0, 0. If x is negative 3, negative is left, so I go 1, 2, 3. 5 is up, 1, 2, 3, 4, 5. And I'll say 5 is up here, just so it's above the 4. And I get negative 3, 5 right there. If I have the point negative 2, negative 4, x is negative, so I go 2 to the left, 1, 2. Y is negative, so I go down 4, 1, 2, 3, 4. And I end up down here. And then lastly, if I have the point 4, negative 1, x is positive, so I go to the right 4, 1, 2, 3, 4. Y is negative, I go down 1, and I'm over here. And again, I am sure you have all plotted points before, so we don't need to spend a lot of time on this. But there are a few things that you can get out of this that we like to ponder and think about in math. So, for the sake of argument, suppose I have the point 3, 2, and I have the point 7, 9. If I graph them, let's see, I get the point x is 3, y is 2, so we'll say it's right here. For the next point, x is 7, y is 9, we'll say it's right here. And then once I have 2 points, well then I can ask a whole lot of questions like, what is the distance between those points? What is the length of that line segment right there? There's different ways to actually find this. There is a formula that we'll go over. But ultimately, one thing you can do is draw a vertical line. I'm making it dotted so there's no confusion. Right through that point right there. Draw a horizontal line right through this point here. And then clearly, that's a right angle where those two meet. And then what have I created? Now I can highlight the part I care about. Well, that's a right triangle. Can I find the value of this point right here? Well, sure. It's directly below this point, so the x value is the same, 7. It's the same height as this point, so the y value is the same too. And now all of you know, if you have a right triangle, the Pythagorean theorem works. A squared plus b squared equals c squared. And I can actually use that to find that distance. So let's see, the length of this side. If the x goes from 3 to 7, that's a distance 4. this side, if the y goes from 2 to 9, that's a distance 7. And then the Pythagorean theorem says 4 squared, which is 16, plus 7 squared, which is 49, equals c squared. 49 and 16 is 65, is equal to c squared. So c is the square root of 65. And now there we go. We're not really doing anything new. We're just using a little bit of geometry that you guys have known for years. And you can always solve the problem this way. If you're finding distances between points in the plane, you can always just plot them, draw a horizontal line and a vertical line, create a right triangle, and use the Pythagorean theorem. If you don't want to do that every time, there's actually a formula that we get out of this. It's called the distance formula to find the distance between 2 points. And as far as it goes, we say the distance between 2 points, I'll call them P1 and P2, is the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, I'm sure it's pretty obvious right here. x2 minus x1 is this horizontal distance right here. y2 minus y1 is the vertical distance here. So what am I doing? Finding the horizontal distance and squaring it, finding the vertical distance and squaring it, adding them together and square rooting. It's just the Pythagorean theorem solved out for you. The assumption is you don't know how to draw this triangle on your own. So somebody just wrote out a formula and said, here, memorize this. As far as it goes for you guys, I don't care which way you do it. You can just use a right triangle like this. That's actually what I use a lot because I don't like memorizing formulas. You can just use the right triangle, memorize it and go with it. Or memorize this formula right here so that you can solve the problem. We're going to do one more example and then look at one more thing. So, suppose we have the point P1, which is 312, and the point P2, which is -4, -6. I could plot the points and draw the triangle, but now I'll actually use the formula just so we can work it out. So we say the distance is the square root of x2 minus x1. So -4 minus 3 squared plus y2 minus y1. -6 minus 12 squared. Make sure you put all your negatives in the correct place. -4 minus 3 is -7 squared, plus -6 minus 12 is -18 squared. -7 squared is 49. -18 squared is 324. And then we get the square root of, let's see if I can add right. 9 and 4 is 13, carry the 1. That's 7, 373. And there we go, we're done. As far as it goes when finding distances, I actually prefer it, and a lot of times Alex and homework will prefer it, if you leave it in an exact form, just like with your solving quadratic equations, leave it in an exact form like this. If it's an application or if the problem says round to 2 or 3 decimal places, then throw it into your calculator and round it. Okay, good. So we have the distance formula. There's one more formula we're going to look at. So again, suppose we have 2 points. 1, 1, and 7, 11. I want to find the midpoint between them. We want to get an idea of what's going on, so we draw a picture. We have the point 1, 1, which we'll say is right here, and the point 7, 11, which we'll say is up here. And I want to find the midpoint between them, which is maybe somewhere around there. Again, there's different ways to go about this, but one thing you can do is essentially say the midpoint is like right there. I don't know what it is, but I'm going to call it XY. Now, do exactly what you did last time, but do it twice. This gets a little bit messy, so just kind of bear with me. But draw a vertical line here, draw a horizontal line there, and then connect those two. Then do the same thing here. Draw a vertical line through here, draw a horizontal line through here, and then connect those two. Just like last time, I can actually find the value of this point. It's the same x value as that, x. The same y value as that, 1. Here, keep changing colors so we keep everything straight. This point is the same x value as that, 7. The same y value as that, y. And then I just need to kind of find a way to relate this point and that point and that point, and then algebraically solve for x and y. It is actually not that big of a deal to do it. You have to use a distance formula and do a little bit of arithmetic. But we're not going to worry about that because I'm sure none of you care because none of my students have ever cared. So we'll leave that off. If you do care, let me know and I'll show you how to do it in class. But all this really tells us is, if you algebraically manipulate it, you can get that the midpoint, we'll call it M, of P1 and P2 is equal to x1 plus x2 over 2, y1 plus y2 over 2. And if you think about it, that is completely logical. The midpoint is in the middle. It's kind of like an average. How do you get an average? You add up everything and divide by the number of terms. So if I want to find the midpoint, the average of those 2 points, I find the average of the x's, add them up and divide by 2. Find the average of the y's, add them up and divide by 2. Once I've averaged the x's and averaged the y's, I should get the average point. So, if we want to do it right here, if those are my 2 points, the midpoint is average of the x's, 1 plus 7 is 8 over 2. Average of the y's, 1 plus 11 is 12 over 2. Which gives me 8 over 2 is 4, 12 over 2 is 6. And I get 4, 6. And again, if you think about it, the x value here is 1, the x value there is 7. Having an x value of 4 in the middle makes sense. The y value here is 1, the y value here is 11. Having a y value of 6 in the middle makes sense. So that's the point, 4, 6. I'm just going to do one more example of this so that we're all clear on how it goes. And again, and we'll just make sure to use the formula this time. So suppose I have P1 equals negative 1, 6, P2 equals 5, 11. To find the midpoint, I average them. Negative 1 plus 5 is 4 over 2. 6 plus 11 is 17 over 2. And I get 4 over 2, 2, 17 over 2. And there's my midpoint. From your perspective, either you have to understand geometrically what's going on so you can kind of generate those triangles and solve problems that way for both the distance and the midpoint, or you have to memorize the formulas. Which one you choose to do is up to you, but you will see problems like this on the exam, so make sure you pick one and learn it and understand it.